So in this question, which is the first question in your homework on Canvas, read the question first. It says researchers are testing this therapy on mice, and it's a treatment for advanced ovarian cancer. So what they're doing is they're injecting tumors with either a placebo, which is a buffer solution. Basically, it's nothing, or the actual treatment, which is the nanoparticle delivered gene therapy, which is injected directly into the tumor. And this is the actual treatment. They want to test how effective this new treatment is in either reducing the size of the tumor or controlling the size of the tumor. So let's look at how this is measured. What they have here, these numbers are the ratio, and this is how the ratio is measured. So at the beginning of the experiment, or the beginning that is before the treatment is administered, the size of the tumor is measured. So let's call it the old size. Let's call it O. And after the treatment has been given, it's either the placebo or the actual treatment, the size after 2 weeks is measured. So let's call that N, the new size. So the fold size of the tumor is the new size over the old size. Now suppose the new size is, the old size, let's say, is 20, and the new side is 20. So this is good news because the tumor has stopped growing. So 20 over 20 is 1, which means no change. So the only way we can get a 1 in this case is when the new size is equal to the old size. So suppose the old tumor was 40. If we want a 1 as the ratio, so ratio is this fraction, then this would have to be 40. So a ratio of 1 would mean that the size of the tumor has not changed. Now, when is a fraction greater than 1? Suppose we want to get an answer which is greater than 1. So for example, if the old size, so we're looking at new size over the old size. Suppose the old size is a 20 and the new size is 40. Then do you see that 20 goes 2 times into 40 and your answer is 2. So this ratio, or this fraction of the new size over the old size, is 2. What that really means is that the size of the tumor doubled. When the ratio is greater than 1, what it means is that the tumor has grown in size. So the tumor has grown if the number is greater than 1. So when is a fraction greater than 1? When the numerator is greater than the denominator. That's when you can get a number. So the fraction would then be greater than 1. So the numerator is the new size, which means the fraction is greater than 1 when the new size is larger than the old size, which means the tumor has grown. Now let's just look at another example real quick. Suppose the new size of the tumor is 60 and the old size is 20. What this means is, so that's 20 times 3 is 60. This means that the new size is 3 times the size of the tumor that was the initial size of the tumor. So the fold increase is 3, which means the tumor has grown 3-fold. What if we had the original size to be 10 and the new size to be 40? The ratio is 4. 4 is greater than 1, which means obviously there is growth in the tumor. and it is 4 times as large. So the tumor is 4 times as large as the size that it started with 2 weeks back. Now, when is the fold size, which is the ratio new over old, less than 1? So let's see. Suppose the old size is 20 and the new size is 5. Do you see that the new size is smaller than the old size? So that's good news, because this tells us that the tumor has shrunk in size. It is a smaller size. So 5 goes 4 times into 20. So you have 1/4. So what this says is that the size of the tumor is 1/4 the original size, which means it has shrunk. If the fold ratio is 0.25, which is smaller than 1, then it tells us that the tumor has shrunk. And suppose we have the old size is 10 and the new size is 2. What we have is 1/5. What this tells us is that the tumor is 1/5 the size. It's 1/5 the initial size. So overall, we know that if the ratio is greater than 1, that is growth. If the ratio is equal to 1, which means the new size is equal to the old size, which means no growth. The growth has stopped completely, which is not bad. And the ratio, if it's less than 1, then what it means is that the tumor has shrunk. Now let's look at these numbers. Let's compare the two sets. So this first set is a placebo. The second one is the actual treatment. If you look at the numbers in the actual treatment are lower than the numbers in the placebo group, which means that the treatment at a minimum has controlled the growth of the tumor. Notice that none of these numbers are less than 1, which means that the tumor size did not shrink in 2 weeks. Whether it was the treatment or obviously the placebo, basically is no treatment, which means the tumors continued to grow. And if you look at the range of values in the buffer solution, which is the placebo group, the numbers range from 3.3 to 9.1. Always, when you say range of values, you have to say the smaller number first. It's anywhere between 3.3 and 9.1, which is pretty high, because this tells us that at a minimum, the tumors tripled in size. 3 means tripling in size. And the largest tumor was a tumor that was 9 times the original size. So that is a lot of growth. So the tumors continued to grow when the tumors were injected with the placebo. In the nanoparticle delivered gene therapy, notice that most of the numbers were between 1.1 and let's say 2.1, which means at a minimum there was almost no growth. No growth is 1. This is slightly larger than 1. So it was almost no growth, or at the worst, it is the tumor has tripled in size. But when you compare it to the placebo group, you'll notice that if you did nothing, then things would have been worse, which means that the treatment is at least controlling the size of the tumor. So compare the numbers. Now, there was one tumor that quadrupled in size, but most of the tumors were in control. from anywhere from 1.1 to 3.5, which means anywhere from no growth, which is almost close to 1, which means the tumor didn't grow. And at the worst, if you kind of look at either this number or this number, at worst, it was like it had tripled in size or doubled in size. But it wasn't as bad as the previous group where it was like almost 9 times the size. So at least the treatment worked in controlling the size of the tumor.